Hi everyone, welcome to the next lecture on ordinary differential equation. In this video, we are going to discuss the most important concept, that is what is homogeneous function and how to solve homogeneous differential equation. So what is a homogeneous function? See the definition, f is called a homogeneous function if it is expressed in the form of f of x comma y equal to x power n phi of y by x. Is it clear? No? So see the example here, f of x comma y equal to x cube plus y cube divided by x square plus y square. Now here we have to take highest power of x common from numerator as well as from denominator. In short, we have to try to write this function in the form of y by x. So if we take x cube common, so here it is a x cube. So from numerator if we take x cube common, so indirectly when we are taking common, that means you have to divide that term to the each term of the remaining term. So here x cube we are taking common, so x cube divided by x cube is 1 and here we will get y cube divided by x cube. So each term of numerator we have to divide by x cube because we are taking x cube common. So x cube divided by x cube 1, or here y cube divided by x cube divided by, here take the x square term common, so remaining is 1 plus y square by x square. Now see this x square and this x cube, x square get cancelled out from this x cube, so here remaining is x. 1 plus, can we write y cube x cube combinedly whole cube? Yes, it is a y by x whole cube, and denominator is, it is a 1 plus y by x whole square. Can we say that this is a function of y by x? When we have given the term like it is a x contain, y contain, so we can say this is a function of x and y. But if we have given this type of term, so it is an expression and it contain y by x, y by x. So we can say this is nothing but the function of y by x. There is a whole cube, whole square. If it is a y cube x square, so then it is not the function of y by x. But because of whole x and y both having same power, so combinedly we can write in the form of y by x. And this is also y by x, because if we write y by x as a new variable t, so it become a 1 plus t cube divided by 1 plus t square. So hence we can say it is a complete term of y by x function. So here this is nothing but the new function, so we can write it is a function of y by x. You can denote the any notation because it is a new function. You can write here g, h, phi, anything. So here x phi y by x, that means it is a function of y by x. Now see here our function, we have taken function x comma y, and that we can express in the form of x phi of y by x. So here the power of x is 1. So we can say the function f, means this our given function, is homogeneous of degree 1. So this is a function is homogeneous of degree 1. So in short, whenever we have given the function and if we are check the power of numerator term, denominator term. So numerator throughout power is same, denominator throughout power is same. So we can say it is a homogeneous function. This is a shortcut way. Otherwise, you have to take highest power of x common, highest power of x common from denominator and try to write that function in the form of phi of y by x. Means each term will be expressible in the form of y by x. It is not allowed we are writing y cube x square. For example, suppose we have given the function, consider the new function, I will take g of x by y equal to x cube plus y cube divided by, here I will take here x square y. Now take the highest power of x common from numerator and denominator. So it is a x cube common, so remaining is 1 plus y by x bracket cube, and denominator if we take x square common, so it become a 1 plus y by x square, this term. Now here x get cancelled, so it is a x. But now see, this remaining term is not a function of y by x because here numerator is y by x whole cube. But in denominator it is a y and denominator here it is a x square. So that means it is not a function of y by x square. So this is not like a x phi of y by x. Here it is a y by x, but it is not a y by x, it is a y by x square. So hence we can say this function is not homogeneous. As in differential equation, when we solve ordinary differential equation, so that time we don't have to apply this process. This process we have already studied in partial differentiation, but sometimes we are forget about what is a homogeneous. That's why I have explained this concept. You just have to understand, if we have given any function, so check the power of that term, numerator and denominator. So is it same? Then we can say here numerator throughout x cube. Here it is a x square, but it is not in the form of square, so it is not a homogeneous. Sometimes there is a function in the form of trigonometric or exponential form. That time this definition only help you to understand homogeneous. So I will take one short example. Now consider the next example. Suppose we have given the function e power x by y plus tan of x square plus y square divided by x plus y, or we will take here x into y. Now here we have to again replace, take the x common from numerator denominator. Now here this is already in the form of x by y, so this is already given in the form of x by y. That's why I am not taking anything common from that power. Here it is a tan of x square plus y square divided by x by y. So you cannot take common from the angle outside the tan, but inside the angle you can take that common. Like here x square, if we take common, so we can write it is a 1 plus y square x square. That's why we write here y by x whole square divided by, here we want y by x form. So y, we need denominator x. So this x is already there. I want denominator x. That means multiply and divided by 1x here. So I have taken divide and multiply by x. So divide and multiply by x here. So we will get x square y by x. Ultimately this x get cancelled. So it is a same term, that is a xy. So it is just an adjustment to write the function in the form of y by x. So this one is extra. So this x square and this x square get cancelled out. So here we can cancel out this term. The remaining will be e power x by y plus tan of 1 plus y by x whole square divided by y by x. Now here this is a complete function of y by x. See here it is a y by x, and this term also we can express as a y by x, because this is nothing but we can take e power, here it is a 1 upon y by x, because 1 upon means if we are take the reciprocal, so it become a x by y. So ultimately this is also expressible in the form of y by x, and this is already tan term is already in the form of y by x term. So hence we can say that this whole term is a function of y by x, because it contains simply y by x, y by x, y by x. So that means this term is a function of y by x. Now see here, the given function is expressible in the form of y by x. So we can say this is also homogeneous function. What about its degree? Here there is no term outside the x, means we have to write x power n phi of y by x. There is no x, that means this is nothing but x power 0 phi of y by x. So hence we can say the degree of this function is 0. So this is also homogeneous function of degree 0. Now we start how to solve homogeneous differential equation. And if you have doubt in the particular question, you can share your doubt in the comment section or in Telegram group, otherwise in Instagram, so that particular question we will try to cover in our next coming video. And in this channel, we are always try to solve your doubt through the videos, so that it will be crystal clear to you. Now see how to solve the homogeneous differential equation. Here is a question, x dy minus y dx equal to root of x square plus y square dx. Now firstly, here it is a x dx term, here also it is a dx term. So this dx term I will shift in the right side, so that dx will be, we will get in the one bracket term. Now we can take dx common. So from this term we will take dx common. Now in the next step, this dx I will shift in the left side, and here x we have to shift in the right side. In short, you have to write in the form of dy by dx. So here the dy by dx equal to, here it is a root of x square plus y square plus 1 plus y divided by x. Now see, this is a homogeneous function. Clearly we can see that it is a homogeneous, because each term here in the numerator power is 1, and here also it is a power 1. If you are understand it is a homogeneous function, you can start solving directly. Otherwise shortly you can check that function, because ultimately that term we can use for solving the next step. Means here you have to take highest power of x common from numerator, and highest power is root of x square, and root of x square is nothing but x, because x square contained in the root, that is nothing but x. So throughout you have to take x square, root of x square means x common, and when we are taking common, so ultimately it is divide each term by the x square. So here root of x square I will take common, so simply we can say it is a x we have to take common, because it is nothing but the x. So throughout take the x common. So what we will get here, root of x square divided by x square is 1, and here y square divided by x square plus y divided by x. So throughout we have taken x common, so this term will be in the remaining. Divided by, here it is a x. This x get cancel out. So see here whole term contain y by x. So we can say it is expressible in the form of phi of y by x. Hence this function is a homogeneous. So we can say that our differential equation is a homogeneous differential equation. If the given differential equation is homogeneous differential equation, the second step is you have to put as a y by x as a new variable. So here y by x we can put the new variable, let's suppose v. You can take any notation, there is simply we have to write y by x as a new variable. You can write t, p, q, anything. So y by x I will consider as a new variable v. So y by x if we put v, so we will get y equal to x into v. Differentiate this term with respect to x, so we will get dy by dx equal to, here both term are the function of x. So we have to use the product rule, because here already showing that it is a x, and v ultimately function of y by x. So ultimately it is a indirectly function of x. So v is also dependent variable. So take the derivative x as it is, derivative of second term plus second term v as it is, derivative of x is 1. So put this value in this equation. So we have to put this in this differential equation. The left side become dy by dx is nothing but x dv by dx plus v. So x dv by dx plus v, and right side term is root of 1 plus v square, because here this is a y by x is nothing but our v plus v. So right side is complete term of v, and here also there is a plus v. So just we have to apply the next step is a variable separation you have to try. So this plus v shifting will be minus. So x dv by dx equal to root of 1 plus v square plus v and minus v. So this plus v shifting will be minus. So ultimately this become a 0. So you can write directly 0, otherwise shift and in the next step write down the 0. So here this term is 0 means remaining is this one. So apply the variable separation. This term shifting will be denominator. So we will get 1 upon root of 1 plus v square dv, and x term I will shift in the right side. So denominator dx will be shifted as a multiplication, and x multiplication we will get in the right side denominator. So it is a 1 upon x dx. Variable are separated. So what will be our next step? Yes, it is a integrating both sides. So integrating both sides, we will get integration of root of 1 plus v square dv equal to integration of 1 upon x dx. Now see here, integration of this term we will get in the form of log. It is a standard formula. Here also we will get log. So that's why I will write the integrating constant also in the form of log. Now here integration of this term is nothing but log of v plus root of 1 plus v square. And integration of 1 upon x is log x plus of log c. Log a plus log c is nothing but a into c. So this is right log of x c, and left side log as it is. Both right and left are in the form of log, so we can take the anti-log so that this log will get cancelled. So it is actually taking anti-log on both sides. So we will get v plus root of 1 plus v square equal to x into c. Now put the value of v, because v is our y by x and we want the answer in the form of y by x. It is a solution of this differential equation. So v is nothing but y by x plus root of 1 plus y square by x square equal to x into c. If we apply the cross multiplication here, so it gives x square plus y square divided by x square, and denominator x square, root of x square is x. So simplify that answer. So in the next step, if we simplify that term, so you will get y by x plus root of x square plus y square divided by x, because root of x square in the denominator is nothing but x. So after cross multiplication, we will write this term xc. Now here it is a x. So both denominator is same. So combined denominator. So we will get y plus root of x square plus y square whole divided by x equal to x into c. And this denominator x, right side shifting will be multiply. So whole simplified answer is y plus root of x square plus y square equal to x square into c. Hence we will get the final solution of our differential equation. So I hope it is clear to you. If you have doubt, you can share your doubt in the comment section.